गुड मॉर्निंग स्टूडेंट्स। आज बात करेंगे हम लोग कुछ ग्राफ्स के बारे में। डिस्टेंस एंड डिस्प्लेसमेंट का ग्राफ विद वर्सेस टाइम। तो टाइम के साथ डिस्टेंस, जैसे सबसे पहले समझते हैं कुछ बातों को डिस्टेंस के बारे में। जैसे डिस्टेंस हमेशा इंक्रीज करे, डिस्टेंस कभी भी निगेटिव नहीं हो सकता। डिस्टेंस इज टोटल पाथ ट्रेवल बाय एन ऑब्जेक्ट। और आप सबसे कॉमन समझ सकते हैं कि जैसे आप बाइक चलाते हैं या फिर कार चलाते हैं और उसमें आप ऑब्जर्व करते हैं ओडोमीटर को। तो ओडोमीटर में क्या आप देखते हैं कि जब आपने नया बाइक खरीदा तो ओडोमीटर में उस समय 000 रहता है। उसके बाद हम उसे चलाते हैं 500 किलोमीटर, 1000 किलोमीटर, 1500 किलोमीटर, लाइक दैट। और आफ्टर दैट यू कांट डिक्रीज दैट value. If you travel 1500 kilometer, then after that you can't decrease it to the 1400 kilometer. It always with time, it always increasing. So this is the concept of distance. And whereas the displacement must be negative, it may be negative, or with time it will also decrease. So this is the difference. And when we draw the graph between distance versus time, then we take care of that words. And if I am taking the time in this axis and distance in this axis, then it will never be negative. Time also never be negative. So the graph will never go this side and this. Only this part is used for distance time graph, because both quantities are always positive. And when you start distance, then it will always increasing. It will never decrease. So graph will never go down. If you are going down, then this is wrong. So in distance time graph, the distance is always increasing. It may be a straight line. For a straight line means distance is not changing, it is straight. And also time is also not negative, or also time will not decrease. So for this graph will not never go like this. This means we are going back in time, but time is never negative. Also, if you draw a straight line from the time axis, then you get 2 points. It indicates that the object is at 2 places at same time, which is also dangerous. So this is distance time graph, in which if the graph is a straight line from parallel to time axis, then it is at rest. If it is making a slope, then it is constant speed. If it is curve means either it is accelerating or deaccelerating. But how we know it is accelerating or deaccelerating? So the slope on the curve, or you can say tangent on the curve, give the speed at that point. So we will draw some tangent. Like we draw a tangent at this point, A point. This is the tangent. Then we draw a tangent at B point. This is the tangent. Then we draw a tangent at C. And what we observe, the slope of the tangent is increasing. It means with time the speed is increasing. This means that the object is accelerating with time. Another graph, if the graph is like that, then what will we observe? We again draw the tangent at this point, then tangent at this point, then tangent at this point. What will we observe for the point A, B, C? That the slope at A, B and C is decreasing with time. This means this object is deaccelerating. Negative acceleration is there. And when it becomes a straight line, then we can say that it comes to rest. So this is the graph for distance. And when we take displacement time graph, if we take displacement time graph, then what will we observe? Displacement may be negative, so this portion and this both portion will be used. Time never be negative, so this and this portion not be in use. And displacement, we know that displacement is negative, so we can go negative side. Also, distance is decreasing, so we can decrease it. So distance is decreasing like that. We graph also it go to the negative sides. So, and in this graph also, it will not go back like that because time is not negative. And for acceleration and deceleration, the same concept is used here in the displacement time graph. Now we see the speed and speed and time. Speed and time. Speed and time graph. If this line is parallel to time axis, then it is constant, moving with constant speed. It will not enter in this side because speed is never negative. So if speed is decreasing, then we can draw like that. This is the graph for deceleration. And if this graph is slope is like that, then this is acceleration. Speed is accelerating with time. It will go up and down because speed will increase or decrease like that. And if graph is curved, then we can say that it is accelerating with ununiform acceleration. There is no uniformity, it is not uniform acceleration. This is a straight line indicate that it is accelerating uniformly, and this is not in uniform motion. It is accelerating with changing acceleration. And if we take the velocity time graph, then velocity, this is indicate constant velocity, and if it is in a negative axis, velocity will come in negative axis because velocity become negative when we are moving. If we suppose a point as origin, and when we consider that this direction is positive and this direction is negative. So when we move in negative direction, then the velocity is in negative axis. And a straight line, again a straight line indicate the acceleration. The only change come with velocity time graph is that it will enter in the negative direction. Like if you throw a ball upside, then the velocity is decreasing with a constant acceleration, that is 9.8 meter per second square, and at the origin, at the highest point it becomes 0, and again when it is coming down, the velocity is increasing. So only this difference will come when we changing from speed to velocity. This is the common way to understand the graph of distance, displacement, speed and velocity. Thank you.